In the early 1930s, the world's leading aircraft manufacturers began seriously considering the development of purpose-built transport and cargo aircraft. It was a time of rapid growth in aviation. At first, the industry often took the path of least resistance, with engineers simply adapting existing passenger airliners for freight duties. A prime example of this approach was the WW2 from the German manufacturer Junkers. Its first prototype took to the skies in October 1930. Just a year later, in the spring of 1931, engineers developed a much more powerful three-engine version. This aircraft proved successful enough to enter mass production the following year. The WW2 served in many roles. It was built as a passenger airliner, a cargo transport, a mail plane, an air ambulance, and even a glider tug. In total, roughly 40 different variants of the aircraft were produced. However, operational experience quickly revealed a major limitation. It became clear that the future belonged to clean-sheet, specialized transport aircraft. A key requirement for these new designs was simplifying the loading and unloading process as much as possible. Simply removing the seats from a passenger cabin would no longer be enough. New design solutions were needed. At the same time, Nazi Germany was pursuing ambitious military expansion plans. To carry them out, the military needed the ability to rapidly airlift bulky, outsized cargo. Specifically, this meant self-propelled, wheeled, and tracked armored vehicles, as well as entire troop units. These plans directly spurred the development of a dedicated military airlifter. Furthermore, by the end of the decade, the WW2 was aging rapidly and could no longer adequately fulfill the military's expanding needs. So, in the spring of 1939, the Technical Committee of the German Aviation Ministry officially laid out new specifications for a future medium-lift transport designed to replace the Junkers. This task was handed to two well-known aviation companies simultaneously, Arado and Henschel, and the objective was clear. The future aircraft had to be powered by two BMW 801 radial engines. Each engine produced 1,600 horsepower at takeoff. In addition to power, the military set strict requirements for the cargo hold, which had to be spacious enough to accommodate two full-sized armored vehicles. Another critical requirement was the aircraft's ability to operate from short, rough, and unpaved airstrips. The companies were given a strict deadline, and by the fall of 1939, they presented their finished concepts to the committee for review. After carefully reviewing the blueprints, the committee ultimately favored Arado's design. The company was immediately awarded a government contract to build the first two prototypes, and the new transport officially received the designation Arado 232. The Arado aviation firm had a notable history. Founded back in 1925, it was established at shipyards in the city of Warnemünde that had previously belonged to a bankrupt industrial conglomerate. In August of that same year, the company Arado Handelsgesellschaft became the full owner of these massive docks. Later, in 1933, the name was changed to Arado Flugzeugwerke. Right up until the end of World War II, the company's engineers developed a wide variety of aircraft. These ranged from passenger airliners to record-breaking sports planes. During the war, the company shifted its focus to transports, heavy bombers, and fighters. One of the company's major achievements over its 20-year history was the creation of the Arado 234, often regarded as the world's first operational jet bomber. As for the new AR-232 transport, its unusual and somewhat futuristic aerodynamic shape was designed by the company's chief designer Wilhelm von Ness. He was facing a difficult engineering challenge. He needed to find a workable balance. The aircraft had to haul large payloads over long distances while maintaining a high cruise speed. It also needed to operate from short, unimproved dirt strips. In addition, it had to remain responsive to the controls in varying weather conditions. To achieve this, the designers made several notable choices. They went with a high-mounted wing design and placed large engines directly underneath it. They also incorporated a widely spaced twin-tail configuration. All of this was done to ensure the aircraft remained stable and controllable, even during aggressive maneuvers or at low airspeeds. The wing structure itself was robust, combining a straight center section with tapered outer panels. The engineering team had to run extensive tests and aerodynamic studies before they could create an effective high-lift system for the wing. In the end, they went with large extendable flaps that took up about 53% of the entire wingspan. When fully deployed, they increased the wing area by nearly 25%. This was one of the factors behind the heavy transport's short takeoff and landing capabilities, especially in difficult conditions. On top of that, during takeoff, the powerful prop wash from the engines blew directly over the wing. Because the engines were mounted right in line with the middle of the flap sections, this engineering choice increased the aircraft's lift by nearly 30%. Thanks to these aerodynamic measures, the designers were able to achieve strong lift characteristics. To ensure the aircraft would not require a long runway, the design team implemented additional solutions. For rapid deceleration immediately after touchdown, they incorporated a drag parachute. And for emergency takeoffs from exceptionally short fields, rocket-assisted takeoff could be employed, commonly known as Arado. Additionally, to further augment lift, the designers incorporated a boundary layer control system that effectively blew the boundary layer off the wing surface. To ensure precise roll control and confident handling, the ailerons were strategically positioned out at the very wingtips. The tail section featured a rather unconventional design. It was mounted on a sturdy boom extending rearward from the main fuselage, which terminated in a specialized tow release mechanism for glider operations. The empennage itself was widely splayed and fitted with twin vertical stabilizers. This was not merely an aesthetic trend of the era, but a practical design choice. It positioned the horizontal stabilizer clear of the heavy turbulence generated by the wing when the flaps were fully deployed. Thanks to this configuration, the empennage could be kept relatively compact with a reduced surface area, which helped minimize drag during flight. During the design phase of the aircraft's cargo hold and main fuselage, engineers considered several important factors. They looked at the required payload capacity and overall dimensions, as well as the most efficient methods for aerial resupply. Even the shape of the tail section was influenced by these mission profiles. After exploring numerous design options, the designers finalized the dimensions for the cargo bay. It measured just over 21.6 feet long, 7.5 feet wide, and 6.5 feet high. These dimensions met the military's stated requirements for payload capacity. To prevent excessive aerodynamic drag on the large transport, the team smoothed out and rounded off the lower contours of the Arado 232's rear fuselage. This modification improved the aircraft's aerodynamic characteristics. However, one of its main strengths lay in its ability to operate from rough, unprepared surfaces. This was made possible by an innovation from designer Wilhelm van Ness, a highly unconventional landing gear system. For regular operations from paved or well-prepared airfields, the aircraft relied on a conventional tricycle landing gear configuration. But its off-field capabilities were especially notable. Positioned directly beneath the transport's belly was an auxiliary gear consisting of 22 small pneumatic wheels. This system allowed the aircraft to touch down on very rough terrain. The aircraft could roll over fallen trees up to 6 inches thick and cross ditches nearly 5 feet wide. Understandably, it could not be fully loaded when performing these extreme landings. Thanks to this unusual wheel system, German troops gave the Arado 232 the nickname Millipede. To minimize turnaround time, an overhead rail and hoist system was integrated directly into the cargo bay ceiling. Additionally, the rear fuselage could be hydraulically lowered to form a convenient cargo ramp. This configuration made deploying troops or airdropping supplies easier and more efficient. The transport's defensive armament consisted of 3 MG-81Z machine guns. One was mounted in the nose with 1,000 rounds of ammunition. A second gun covered the upper fuselage with 1,600 rounds. The third gun was positioned to cover the rear ramp, carrying the largest ammunition supply of 2,000 rounds. In early June 1941, engineers completed the first AR-232 prototype. That same month, it took to the skies for its maiden flight. However, things did not go exactly to plan. During touchdown, the main landing gear collapsed. This is where the Millipede setup prevented more serious damage. The aircraft settled onto the auxiliary wheels, rolled across the ground, and came to a safe stop. After this incident, lead project engineer Hans Rebeski extensively redesigned the gear mechanism. These changes paid off, and the second test flight proceeded without incident. A second prototype was soon assembled, and the team decided to arm it from the outset. However, the weapon configuration differed slightly from the original blueprints. In the nose, they mounted a 13mm MG-131 machine gun with 500 rounds of ammunition. An identical machine gun was mounted above the cargo ramp. They also installed a 20mm MG-151 cannon. These experimental prototypes provided the basis for subsequent production. There is a popular claim that only 2 AR-232s were ever built, but archival records indicate that factories actually assembled 10 of these aircraft. These made up the initial pre-production batch. Seeking improved flight performance, the German Air Ministry ordered Arado to rapidly develop a new, larger version. This was the 4-engine AR-232B variant. The heart of this upgraded aircraft would be its BMW Brahmo 323R2 Fafnir engines, each produced 1,000 horsepower. At first glance, one might think that redesigning the aircraft to meet these new requirements would be a major undertaking. But in practice, the solution proved comparatively simple. This reflected how flexible the transport's original design was. To add 2 extra engines, the engineering team mainly had to widen the wing center section. No major structural overhauls were required. In May 1942, the first 4-engine variant of the AR-232 took to the skies. A second prototype followed closely behind. The German High Command was in a hurry. As a result, after a highly accelerated flight test program, production of the first batch began immediately. This batch consisted of 18 transport aircraft. Right from the AR-232's development phase, the plan was to use these aircraft for heavy transport missions across a wide range of climates. They were meant to fly everywhere, from the heat of North Africa to the Arctic. To ensure the aircraft could operate in such different conditions, special winter and summer equipment kits were included as standard. The aircraft always carried a backup radio system, a rubber life raft, an oil heating system, an independent engine starter, and a wide array of tools. This allowed the crew to handle their own repairs, even when far from home base. But those plans for the AR-232 had to change quickly. That shift came when the German 6th Army was encircled at Stalingrad. On September 13, 1942, Reichsmarschall Hermann Göring personally summoned Arado's commercial director, Walter Blum. He issued an order to immediately hand over the initial prototypes of the new transport to the Luftwaffe. These aircraft were slated to join the airlift operation. Their mission was to fly in supplies and evacuate wounded soldiers from Friedrich Paulus's trapped army. For Arado, this order came at a difficult moment. The aircraft were still undergoing initial factory trials and were not ready for frontline service. The aircraft's chief designer, Hans Rebeski, strongly opposed the idea and openly voiced his frustration. But in wartime, the decision was enforced. After consulting with Luftwaffe headquarters, Walter Blum decided that, to fulfill Göring's order, Rebeski himself would deploy to the Soviet Union alongside his aircraft. His job was to train the pilots directly on the front lines. He also needed to troubleshoot any technical issues that arose under combat conditions. However, carrying out this urgent order soon ran into a serious obstacle. Just before his scheduled flight to the Eastern Front, Rebeski was involved in a severe car crash and sustained moderate injuries. This made it physically impossible for him to make that first flight to the Soviet Union. Those injuries from the accident ultimately saved the designer's life. Here is what happened. Around noon, the crew of the first Arado 232 flew into a blinding snowstorm over Poland and became completely disoriented. Instead of turning the transport around, the pilot elected to descend. He was hoping to break out of the weather, get a visual on the ground, and determine their exact position. But that decision proved fatal. The heavy aircraft crashed into a dense forest, triggering a massive explosion. The entire crew was killed instantly. The cargo intended for the encircled German troops at Stalingrad was lost as well. The second prototype, however, had a different fate. It reportedly performed well while hauling cargo into the besieged city in January 1943. During one of these supply runs, a notable incident occurred. As the German transport approached its field near Zhytomyr, the crew noticed something alarming. About 20 Soviet fighters were circling the area, waiting for a target. Realizing the danger, the AR-232's aircraft commander made a quick decision. He chose to put the big transport down in a standard snow-covered farm field nearby. Crews flying other aircraft without specialized ski landing gear would not normally have considered such an off-field landing. But for this Millipede and its unconventional undercarriage, it was within its capabilities. Early the next morning, using its internal starting system, the aircraft safely took off. It made an uneventful flight back to Zhytomyr. Alongside this particular AR-232, a few other transports from the initial production batch flew risky supply missions. These took place around Stalingrad during the winter of 1942 and 43. The German Millipedes continued flying into the encircled pocket until General Paulus's 6th Army finally surrendered. Meanwhile, the original plans to operate the new transport in harsh Arctic conditions had not been forgotten. On July 17, 1943, AR-232 pilot Rudolf Schutz took off from the airfield in Brandenburg. He set a direct course for the remote Norwegian airbase at Banak, far to the north. To cover that kind of distance without refueling, auxiliary fuel tanks were installed in the fuselage. This modification boosted the total onboard fuel capacity to 5,000 liters, or roughly 1,300 gallons. Operating out of Banak, Schutz and his crew flew regular missions to the Spitsbergen archipelago. Their primary mission was dropping off complex automated weather station equipment. On July 24th, during a landing on the southern cape of Spitsbergen, things went wrong. A hard landing bent the right main landing gear strut. The massive aircraft rolled out on its unique multi-wheeled undercarriage. When it finally came to a stop, it listed heavily to the starboard side, scraping its wingtip in the snow. But the crew remained calm. The pilots managed to level the heavy aircraft on their own, without any ground support or special equipment. To do this, they used the long travel in the landing gear's oleo struts, essentially turning them into a makeshift jack. On another occasion, on August 7th, the AR-232 ran into a different problem. After touching down on Bear Island, the aircraft bogged down deep in the muddy, thawed-out permafrost. It sank right up to the wheel hubs. The crew spent the entire day digging the aircraft out of the mud. It was not until late that evening that the effort paid off. This finally allowed the aircraft to take off and head back to Banak. On August 26th, this same aircraft returned to Brandenburg for scheduled maintenance and a major upgrade. The plan was to rebuild it into a more powerful 4-engine variant, but those plans never came to fruition. Radio contact with the AR-232 was lost almost immediately after taking off from a Norwegian airfield. The subsequent investigation into this crash, which killed the pilot in command, revealed a sequence of events. It turned out the right engine completely failed just after takeoff. This happened during the climb-out, right as the airplane entered a low, dense cloud layer. To save the aircraft and attempt an emergency landing, the pilot had to immediately counter a severe right bank caused by the asymmetric thrust, and then turn the heavy transport around to make it back to the field. It was a difficult maneuver. While a single working engine might have been enough to maintain level flight, climbing in those conditions was virtually impossible. Captain Schutz chose to trade altitude for airspeed. However, the heavy transport began descending rapidly. The AR-232 suddenly broke out of the thick clouds at barely 500 feet AGL. Dead ahead loomed rugged, rocky terrain. Trying to clear the mountain ridge, Schutz bled off the critical airspeed needed to keep the aircraft flying. The transport stalled, dropped onto the ridge, and burst into flames. The captain was killed in the crash, while the rest of the crew survived and were able to leave the aircraft. Historical documents give us a detailed look at the design of the later variant of this transport, the 4-engine AR-232B, which older records mistakenly identified as the AR-332. One of these aircraft ended up in Soviet hands after a rough landing near the village of Kuklovo. Soviet aviation engineers inspected the captured plane and compiled the following report. The German 4-engine military transport, the AR-232, was an all-metal high-wing monoplane featuring a twin tail assembly mounted on a lengthy tail boom. Its most notable feature was the landing gear system. It actually had two distinct sets. One was a conventional retractable tricycle gear, while the second was a unique multi-wheel system resembling a caterpillar track that remained permanently extended. This transport was operated by a crew of 5. The AR-232 was designed specifically for heavy tactical airlift. This included transporting oversized cargo, hauling heavy weapons, and conducting large-scale paratroop drops. To accomplish this, it featured a large internal cargo hold measuring nearly 33 feet long, over 8 feet wide, and 6.5 feet tall. Complementing this functional design was a large rear cargo hatch, which made loading heavy equipment easier. Its dimensions were substantial. The overall length of the aircraft was approximately 74 feet, with the fuselage alone making up 46 feet. It had a wingspan of 115 feet and a total wing area of over 1,500 square feet. At maximum gross weight, this aircraft weighed nearly 40,000 pounds, and it could haul a payload of around 14,500 pounds. A stylized elephant was painted on the side of the fuselage. This nose art was integrated into the camouflage scheme and likely referred to the aircraft's size and hauling role. Even though the aircraft was heavily damaged during its crash landing, inspecting the AR-232's wreckage provided valuable insights. Soviet specialists learned a great deal about its design, which was advanced for its time. The sections of the aircraft that survived relatively intact included the fuselage, tail boom, and flight controls. Portions of the empennage and the wings also survived. The wing itself featured a robust, all-metal stressed skin and was composed of 3 main sections. The center section was built directly into the fuselage and housed all 4 engines. 2 removable outer wing panels were attached to this center section. Special extending flaps ran along almost the entire wingspan, accounting for nearly 40% of the wing chord. When deployed, they significantly increased the total wing area, improving handling and stability at various airspeeds. When deflected downward, they functioned like conventional trailing edge flaps. The fuselage also featured an all-metal construction. The heavily glazed greenhouse-style nose housed a spacious flight deck with the 2 pilots sitting side by side up front. The workstations for the radio operator, gunner, and navigator were positioned directly behind them. The rest of the fuselage was separated from the cockpit by a sturdy bulkhead, with the entire space dedicated to a large cargo hold. The crew entered the aircraft through a door on the port side, while all loading and unloading was done through the tail section. To handle heavy cargo, a special monorail system was mounted to the ceiling of the cargo hold. An overhead winch ran along this rail, capable of lifting up to 4,400 pounds. Sturdy tie-downs were built into the floor and walls to secure crates and vehicles. For troop transport, fold-down bench seats along the walls could accommodate up to 24 paratroopers. The design was capped off by a distinctive tail assembly featuring twin vertical stabilizers mounted on an extended boom. This transport aircraft boasted a very unusual landing gear system. The main gear consisted of 3 wheels that retracted hydraulically during flight. But the most interesting feature was that the main struts essentially functioned as hydraulic jacks. They could smoothly lower the entire aircraft onto a fixed, multi-wheel auxiliary undercarriage and then raise it back up. This all-terrain auxiliary gear looked somewhat like a tank tread. It consisted of 10 pairs of smaller wheels, each equipped with spring shock absorbers running directly beneath the centerline of the fuselage. Its primary job was to ensure safe landings on rough, unprepared, or muddy airstrips, as well as heavily damaged runways. During these rough field landings, the main gear struts would simply compress and act as outriggers, keeping the aircraft from tipping over. The loading process was designed around this feature. It took place while the aircraft squatted down on its multi-wheel undercarriage. The crew achieved this by retracting the nose wheel and bleeding hydraulic pressure from the main struts to compress them. Next, a section of the cargo bay floor folded down to ground level to form a loading ramp. At the same time, the rear cargo door rotated upward to sit flush with the ceiling, creating a large opening into the hold. Once loading was complete, the whole process was reversed to raise the aircraft back up. Both taxiing and takeoff were then performed using the conventional tricycle landing gear. Powering this aircraft were 4 12-cylinder, air-cooled BMW 323 engines. Each engine generated approximately 985 horsepower for takeoff. The engines were fitted with 3 bladed wooden propellers. To reduce the aircraft's visibility during night operations, the exhausts were equipped with flame dampeners. These not only muffled the engine's roar, but also concealed the exhaust flames in the night sky. The oil coolers were tucked away under the engine cowlings. As for fuel, the center wing section held 4 tanks. Each had a capacity of 132 gallons. For extended missions, 3 additional tanks could be used, holding 317 gallons each. They could be mounted on special brackets right in the cargo bay, alongside a spare oil tank. With this fuel load, the aircraft could fly nearly 1,990 miles without refueling. To defend against enemy fighters, the aircraft was armed with 6 MG-81 7.92mm machine guns. Each gun was supplied with 750 rounds of ammunition. They were positioned to keep blind spots to a minimum. 2 guns were set on flexible mounts right in the nose of the aircraft. Another two protected the aircraft from a dedicated dorsal turret. The final pair was placed on a flexible mount under the tail boom. On top of that, firing ports were built into the windows of the cargo hold. This allowed the airborne troops to return fire in mid-flight with their own rifles and submachine guns. This transport did not carry a bomb load or heavy armor. It was built for a different set of missions. Communication with command was handled by a few G-16 radio set, along with an extra portable radio. As for its flight performance, this aircraft could reach speeds of up to 217 miles per hour at an altitude of around 13,940 feet. Its maximum operational ceiling ranged from 21,300 to 22,900 feet. Toward the end of the war, these AR-232 transports still took part in several risky and secret missions. One of those German operations went under the code name Scherhorn. In the summer of 1944, following the collapse of the German Army Group Center, the remnants of several German units found themselves surrounded. One of these pockets was commanded by an officer named Heinrich Scherhorn. At first, he tried to break out to the west to reach friendly lines, but he later received orders to organize a guerrilla campaign behind Soviet lines. This period was later depicted by the writer Vladimir Bogomolov in his novel The Moment of Truth. The German command planned to use 6 Arado 232 transports from a special squadron. Their goal was to keep Scherhorn's group and similar units supplied and eventually evacuate them. But events unfolded differently. When the operation finally began on December 8th, they could only assemble 2 aircraft for the job. All the way up to February 1945, these transports managed only a few scattered flights, trying to drop supplies to the trapped forces. These supply runs were irregular. This was due to a combination of poor weather and continuing technical issues with the planes themselves. They also faced opposition from Soviet fighters. Despite these efforts by the Germans, the operation proved ineffective. Soviet intelligence had conducted a successful deception effort. In reality, Heinrich Scherhorn had been captured much earlier. Meanwhile, the German High Command kept receiving forged radio messages and believed the mission was still viable. Interestingly, one of the 2 AR-232 aircraft used in this operation eventually fell into British hands. Since the aircraft was in good condition, it was put through a thorough flight test program. RAF test pilot Eric Brown personally flew it and later noted its favorable handling characteristics for a transport. After World War II, the aircraft saw use flying cargo runs between Great Britain and Germany. Later, in November 1945, it was put on display at an exhibition of captured enemy aircraft at Farnborough. Meanwhile, Arado engineers kept working to improve their transport aircraft, despite constant setbacks and defeats on the front lines. Their new, upgraded version was designated the AR-432. The biggest difference from the base model was its mixed construction. The outer wing sections and the tail unit were now made of wood. This was done to conserve strategic materials that were in short supply. In June 1944, the Luftwaffe Chief of Staff personally visited the town of Landeshut. He was there to meet with the design team and discuss their near-term plans. Among other things, they briefed him on the new AR-432. He left impressed both by the aircraft's design and by the team's overall approach. Following this visit, development on the AR-432 accelerated. To avoid wasting time, the engineers used a few of the earlier AR-232 prototypes as flying test beds. Some aircraft were used for general flight research, while others tested new systems and airdrop techniques. A few more airframes were brought in to test handling across various flight conditions. Meanwhile, the first pre-production AR-432s were used specifically to establish the baseline flight performance of the upgraded design. According to company archives, on June 6, 1944, Chief Engineer Walter Bloom made a firm decision. Determined to keep the program on schedule, he ordered the acceleration of the first AR-432 prototype's construction. Just days later, on June 10th, the management team decided to begin full-scale production of the AR-432 by October of that year. Unfortunately, it is not clear from historical records whether those first 2 prototypes were ever actually finished. All we know for sure is that by the end of the war, a few fully assembled airframe components were discovered in the town of Eger. Meanwhile, the new AR-432 transport was officially showcased at the last major German air show in Lehrtz. This event was held on June 12th and 13th, 1944. However, this presents an interesting question for aviation historians. Most likely, the aircraft on display was not actually a new AR-432, but rather an AR-232 testbed. It was temporarily redesignated to present it as the new variant. This theory is supported by the crash of one of these older airframes on June 14th near Rechlin. Looking at the timeline of the exhibition and the crash, it becomes apparent that this specific aircraft could not have made it to the test range in time. On top of that, there is an internal report from Arado's development department dated June 22, 1944. This document clearly states that one of the test transports was transferred to the test center back in early June. This specific airframe was originally intended for paratrooper drop tests. The conclusion seems fairly clear. What was shown to German leadership and the public at this exhibition was likely a slightly modified earlier model, presented as the AR-432. Another report from June 17th described test flights at the Rechlin Proving Ground. It noted that 4 trenches were dug across the designated landing area for the AR-232. They were about 5 feet deep and topped with a sand berm roughly 2.5 feet high. To further simulate rough frontline conditions, the ground between the trenches was completely covered in small pits, designed to mimic artillery craters. It was on this kind of torn-up landscape that the aircraft performed its takeoffs and landings. During one test, it touched down directly over a dugout trench. It completed its landing roll without serious difficulty. For the VIPs and observers watching, this rough field capability made a strong impression. Beyond the AR-432, German engineers were also drawing up even larger versions of the transport. Specifically, they were developing the AR-532 and other related variants. All of these ambitious projects shared a similar design language. They had a wingspan of almost 200 feet, were powered by 6 engines, and featured the same auxiliary landing gear system equipped with 30 wheels. However, by the end of 1943, mass production of the AR-232 had to be halted. This decision was made to free up factory space and increase the output of FW-190 fighters. Those aircraft were in high demand on the front lines at the time. Overall, the AR-232 proved to be a capable replacement for the Ju-52. The new transport cruised over 40 miles an hour faster than the older aircraft. On top of that, its payload capacity was roughly double. In the end, what was arguably one of the first purpose-built tactical transports met an unremarkable fate. Even though it was designed to operate from unprepared dirt strips, the program was curtailed near the end of World War II by Luftwaffe bureaucracy. The goal at that point was to streamline logistics and reduce the number of different aircraft types in service. As a result, the AR-232 never achieved the same level of recognition as its predecessor, the Ju-52.